Let's look at some word problems that involve systems of equations. For the first one, a basketball team has played 66 games. They won 24 more than they lost. We want to know how many did they win and how many did they lose. Well, first, let's establish some variables that make sense to us. Let's let the number of wins be represented with the letter W, and let's let the number of losses be represented with the letter L. Now, it's not possible for us to tie a basketball game. So that means the number of wins that we have plus the number of losses that we have should give us the total number of games that were played. The wins plus the losses give us the total number of games played, and there is our first equation. Now, the number of wins and losses are not the same as each other. It tells us that they won 24 more than they lost. So W and L are not equal. If you wanted the number of wins and the number of losses to be equal, you would have to add 24 to the number of losses. The wins would equal however many you lost plus 24 more for these two sides to be equal to each other. That gives us our system of equations. One of the equations came from the total number of games. However many we won plus however many we lost gives us the total number of games. The second equation comes from equating the number of wins and losses. Since wins and losses were not equal to begin with, add 24 to the loss side. Now, this problem is set up very nicely for us to work with substitution because W is already on one side of the equation by itself. Anywhere that we see a W, we can replace it with L plus 24 since that's what W means. So let's take this information and let's use it in the other equation, replacing the W that is here with what W means, L plus 24. When I do that, replacing the W with L plus 24, bringing down the other L and the 66 gives us a new equation that just has L as its variable. Looks like I can take those parentheses away and combine the like terms. Here is an L and a second L. Those add together to be 2L. Bring down the 24 and the 66. If we subtract 24 from both sides, that gives me 42. And if I divide both sides by 2, the number of losses would be 21. Now, if I know the number of losses, I can go right here, substitute 21 in for L, and figure out what W is going to be very easily. If the number of losses was 21, then the number of wins is 21 plus 24. Looks like the number of wins was 45. Notice that we don't have a fraction and we don't have a negative number involved. We can't win half of a game. We can't lose a negative number of games. So we had to have positive integers for our solutions. Also notice that if we take the number of wins that we have and we add to it the number of losses, 45 plus 21 gives us the 66 games that we played. So looks like our answer is correct. Let's look at a second problem. For the second problem, Ms. Suzuki has $18,000 that she would like to invest. She's putting it into two separate accounts. One of the accounts pays 7% interest, while the other account pays 8% interest. We know how much total interest she's received for the year, $1,400, and we want to know how much did she invest in each account. Well, first, we need to establish what our variables are going to be. Let's let X be the amount of money that she invested at 7%. And let's let Y be the amount of money that she invested at 8%. So now, if you take the amount of money invested at 7% and you add to it however much you invested at 8%, this will give you the total amount that was invested. So what we invested at 7%, X, plus what we invested at 8%, Y, should give us the total amount that she had to invest, which was $18,000. Now let's see if we can figure out about the interest. The interest received on the 7% amount, it's 7% of the amount invested. When you hear that word of as a mathematician, that means you're going to multiply. So to figure out how much interest she got in the 7% account, you want to do 7% or 0.07 times the amount of money that was invested there, which was X. 0.07X, that is the interest that we received in the 7% account. Likewise, the interest on the 8% account is 8% of what you invested in the 8% account. Remember, we called that 8% amount Y, so the amount of interest is 8% of Y. Of means multiply, so 0.08 times Y. The total interest would be arrived at by adding together however much interest we got at the 7% amount plus however much interest we got at the 8% amount. That gives me the total interest that we received, which was $1,400 for the year. Now, I personally don't really like those decimals, so I would like to get rid of them. It's easy to get rid of them by multiplying both sides by 100. That just moves every decimal 2 places to the right. So instead of 0.07x, I'll have 7x. Instead of 0.08y, I'll have 8y. And now if we multiplied the left by 100, we have to also multiply the right by 100. So 1,400, let's add 2 zeros to it, and that gives me 140,000. That just makes it a little bit easier to work as a system of equations, in my opinion. So now the two equations that we've got would be these. The total amount of money that we invested at the 7% amount plus the total amount that we invested at the 8% amount gives me the total amount that we had to work with. The interest that we earned at the 7% account plus the interest that we earned on the 8% account gives us the total interest that we had, and we've moved the decimal to take care of that. So there is our system to solve. I want to do this one using elimination, and I'll do that by multiplying the top row by -7. Can you tell which variable I'm trying to get rid of? If I multiply up here by -7, that will make the x's opposite of each other. Let's see what happens. When we've multiplied the top by -7, it gives us this new top row. Remember, we had to multiply everybody all the way across by -7. Once we have those opposite coefficients, then we can add the two rows together. The x's are going to eliminate. Here, -7y plus 8y gives me just a y, and 140,000 minus 126,000 gave us 14,000. So our Y value, the amount that we invested at 8%, is 14,000. Now, I needed to know both of the account values, though. We've only so far figured out the 8% amount. I still need to figure out the 7% amount. Remember, one of our equations said x plus y equals 18,000. If I know that y is 14,000, put 14,000 in here. X plus 14,000 equals 18,000. If you subtract 14,000 from both sides, looks like X is 4,000. So the amount that we invested at 7% is 4,000. The amount invested at 8% is 14,000. Be careful as you answer the question that you type it in the appropriate spot. The 7% amount was 4,000. The 8% amount was 14,000. Let's look at one more. Here we've got a collection of quarters and dimes. The total value of our collection is $14.15. And we know that we've got 77 coins altogether. We want to find out how many of each coins we have. Let's start by establishing a variable that makes sense to us. Let's let Q be the number of quarters. let's let D be the number of dimes. Now, it told us that there were 77 coins altogether. So if we take the number of quarters and we add to it the number of dimes, that should be the total number of coins. The quarters plus the dimes give me the total number of coins that we had. Now, how do you know how much money you have when you look at a handful of quarters? You take however many quarters there are and you multiply them by their value. 1 quarter is worth 0.25. So to get the value that we have in quarters, let's take 0.25 times however many quarters we have represented by Q. 0.25 times Q gives me the number of quarters. Just the same for the dimes. If you had a handful of dimes and you wanted to know how much money was it worth, you would take however many dimes there were, you would multiply by 0.10 the value of a dime. So 0.10 times the number of dimes gives me the value in dimes. If I add these things together, it will give me the total value of our coin collection. However much money I have in quarters, plus however much money I have in dimes gives me the total of our coin collection, which was $14.15. Now, again, I don't really like those decimals, so I'm going to choose to multiply everybody by 100 to move the decimal 2 places, and that will give me something that is easier to work with. When I move the decimal 2 places all the way across, that's the same as multiplying by 100 on both sides. It gives me 25Q, 10D, and be sure that you multiply on the right-hand side as well. So 1415 with the decimal at the back. Now, this gives us a system of equations to work. The first equation was total number of coins, however many quarters plus however many dimes, equals the total number of coins that we have. The second equation comes from value. The value of the quarters plus the value of the dimes gives me the value of the collection altogether. Remember, on that second equation, we've moved the decimal to make it easier to think about. Now, for this one, I'm going to choose to multiply the top row by -10 and do elimination. Can you tell which letter I'm trying to get rid of as I multiply by -10? That will make the D's opposite of each other if I do that. Multiplying by 10 is always something easy to work with, so that made it easier to get rid of D, in my opinion. The top row, when I multiply it by -10, -10 times Q gives me -10Q, -10 times D gives me -10D, and 77 times -10, that's -770. Let's add the rows together. 25Q minus 10Q gives me 15Q. The D's are going to add out like we expected them to, and 1415 minus 770 ends up being 645. If you take 645 and you divide by 15, that'll tell us that the number of quarters was 43. Now remember, if you have 43 quarters and you add to it the number of dimes, that'll give you the total number of coins that we have, which was 77. So 43 quarters plus the number of dimes equals 77. Let's subtract the 43 from both sides, and the number of dimes would be 34. Again, our numbers that we ended up with, they couldn't be a fraction. They couldn't be something negative. We had to have positive integers only for our solutions here. 43 quarters, 34 dimes in our collection, and those numbers do add up to 77.